Alright, tonight's homework assignment is from page 97, and what we're looking at today is really a lot of review where we are comparing and ordering integers and fractions and decimals. Alright, so we're looking at numbers 14 through 28 first. Okay, be sure that you see that it doesn't say 14 through 28 even, it just says 14 through 28. So please be sure that you aren't skipping and assuming that you're doing just the positives. Okay, on number 14, we are comparing -3 and 5 using greater than, less than, or equal to. So -3 and 5. Well, we talked about in class that every positive is greater than every negative. So we're going to have the sign opening towards the 5. So this would be a sentence that reads -3 is less than 5. This line underneath is not part of the sign. -3 is less than 5. Okay, so that's what we're going to do for this entire section. I'm going to skip over 15 and look at 16. On 16 we have -6 minus 3, and we're comparing that to -9. We need to simplify on the left-hand side. -6 minus 3 gives us -9. So now we have -9 on the left, -9 on the right. Hopefully now we can see that those are equal on number 16. Alright, so that's all we're going to be doing on that section. Okay, let's look a little farther down at number 20. On number 20, now we don't have integers, now we have fractions. We have 14/5, and we're comparing that to 25/13. We said one of the ways that we can compare fractions is by changing them to their decimal equivalent. That means change this from a fraction to a decimal. So that's 14/5. You can also think of that as 14 divided by 5. So if we change that to a decimal, that's going to be 2.8. 25/13. If we change that to a decimal by dividing 25 by 13, we get 1.923, bunch of numbers that come after that. Okay, that's enough to see that 2.8 is greater than 1.9. So 14/5 is greater than 25/13 on number 20. All right, let's look at number 21. 21 is a little bit different because we have to perform an operation before we compare the two. 4/3 times 6, and we're comparing that to 4 times 3/2. All right, if we're multiplying 4/3 by 3, we can think of, or 4/3 by 6 rather, we can think of 6 as 6 over 1. We're going to multiply the numerators and multiply the denominators. So 14 times 6 is 24. 3 times 1 is 3. On the right-hand side, we have 4 times 3/2. We can think of the 4 as 4 over 1. 4 times 3 is 12. 1 times 2 is 2. So now rather than having an operation of multiplication that we need to perform, we have two fractions that we're comparing. Just like on the previous problem, we need to change these fractions to decimals so that we can get a better feel for it. 24/3, when we change that to a decimal, well, that's going to give us 8. This is just the whole number, 24 divided by 3. 12 divided by 2 gives us 6. So we should be able to see that 8 is greater than 6. Again, don't be fooled by this line underneath. That's just 8 is greater than 6. That's not part of the answer. All right, so those are numbers 14, 16, 20, and 21. Okay, the next section that we're looking at, we're still comparing fractions, but in this case, we're going to be ordering them. They're going to not just be two fractions, they're going to be 3. We're going to handle these just the same. If we're given 3 fractions, then we'll change all 3 of them to decimals. Okay, we'll look at number 23 to start off with. Number 23, we have 6/7, 2/3, and 3/8. The directions say to change or to write the numbers in each set in order from least to greatest. In order from least to greatest. Well, if we change 6/7 to a decimal, 6 divided by 7 is 0.85. It's probably enough to help us out. 2/3 as a decimal. We're going to get 0.6 repeating. 3/8 as a decimal. 3 divided by 8 is 0.375. Remember, when we're comparing decimals to figure out which one is greater, we need to just look at the first number to the right of each decimal. We have an 8, we have a 6, and we have a 3. Just because the 0.375 has more numbers, that doesn't necessarily mean it's greater than 0.6. Okay, so we have 8, 6, and 3. By comparing those three numbers, we hopefully see that 3 is smallest, so 0.375 is least. So 3/8 would be our fraction in the series that comes first. I'm going to cross that out so I don't accidentally use it twice. Now we have 0.8 and 0.6. Well, the 0.6 is less, so the 2/3 would come next. Scratch it out. The only one remaining is 6/7. So that's what we're going to do on that section. Change each fraction to a decimal and then compare them. It's 14 through 28. As you look over to the back, we're going to be looking at some review problems. Okay, numbers 40, 42, 45, 46, 48, and 49. Let's look at number 45. 45 is something that we haven't talked about today. It's just a preview of what we're going to look at tomorrow. It says to graph this set of numbers on the number line. We have -3, -2, 2, and 3. So graph them on a number line. We know that 0 divides the positive and negative numbers on the number line. So I'm just going to number 1, 2, 3 to the right, and the opposites of those on the left, -1, -2, and -3. So -3 would be here, -2, 2, and 3. This is just a preview of what we'll be looking at tomorrow. Okay, 48. 48, we are reviewing patterns. The directions say find the next three terms in this sequence. We start with 1, then we have 3, 9, and 27. Well, it looks like the pattern here is times 3, times 3, times 3. The directions say find the next three terms. So 1, 2, 3. We need to take 27 and follow that same pattern. Times 3. Whatever we get, multiply by 3. Whatever we get again, multiply by 3. 27 times 3 is 81. And 81 times 3 is 243. And then 243 times 3 gives us 729 on number 48. Number 49, the directions say to write a verbal expression for 2x squared plus 6. Your answer or your verbal expression might not look exactly like the one I write here. Okay, there are a lot of different ways that we can read that. Remember, when you're writing a verbal expression, it's really just how would you read that? Okay, the most simple way, or the simplest way, is to say 2 times x squared plus 6. But we can also say the sum of twice a number squared and 6. Or we can say 6 more than 2 times x squared. Or we can say the product of 2 and x squared increased by 6. Okay, any of those ways on number 49 would work. Okay, it only says to write one. So the answer that we see on that tomorrow may look different than the one that you have. It doesn't mean that it's necessarily wrong.